Today's lesson, section 12.4, we're going to cover a couple of topics. We're going to teach you what it means to find the interquartile range. You probably are familiar with the range of a set of data. You probably got that a couple, 3 years ago. But what does it mean to determine the interquartile range? And then this other statistical measure known as standard deviation. And then we're going to talk at the end of this lesson about what is a z-score and how do we find it. So I can kind of summarize this entire lesson, and you can see by the standard that we're addressing here, we're really analyzing, in this case, the distribution of the data from the mean, and the word spread here is used, and that's a good word. We're trying to determine just how spread apart from the mean our data is. And speaking generally, typically the more spread out our data is, if we're trying to come up with some sort of draw a conclusion from the data, if it's really spread out from the mean, in other words, it's kind of all over the place, it's really difficult to draw any definite conclusion from that data. Whereas if the data are pretty consistent, the data falls within a reasonable margin from the mean, then that's information that we can rely on, we can have more confidence in to make decisions. And so the other day in 12.3 we were focused on the middle of the data. We were doing mean and median and focused on what the middle of the data could tell us. And we had to remember that we got to be careful with just using those measures, because we have things like outliers that we were talking about that can skew the data, skew the mean. And so we can't always just depend on focusing on the middle. In statistics, we call what we did in section 12.3, we were analyzing measures of central tendency. Well, today, think about measures that help us identify, compare data, and the spread of the data from the mean. Okay, and we've got some definite tools, statistical measures that help us do that. So let's address one of those, and we're going to review range. And you probably already know that range means the highest value in the data set minus the lowest value. So let's just go ahead and get that taken care of real quickly. The directions here tell us to find the range and the interquartile range. Well, the range, pretty easy, is the highest number, 26, minus the lowest number, 16, so we have a range of 10. Well, what does this interquartile range refer to? Well, going back to our lesson in 12.3, we talked about quartiles and how to find quartiles. Well, that begins with finding the overall median of the data set, the number that's in the middle. And for this particular set of data, the number that's in the middle, of course, remember, you have to arrange the data from lowest to highest. The number that's in the middle is the number 20, and we call that quartile 2, or Q2. Well, Q2 divides our data up into two smaller groups, and there should be the same number of numbers in each group. In this case, I've got 4 numbers to the left of Q2 and 4 numbers to the right. Well, the other quartiles are the middle numbers, the medians of these other smaller groups. So my median of the left 4 numbers, the one that's in the middle, is 16.5. And we call that Q1. And then I jump over here to the 4 numbers to the right of Q2, this small group, and I find the median of these 4 numbers. And that's 24.5, and we call this Q3. Okay, so interquartile range, now that we know what our quartiles are, interquartile range, I'll just abbreviate it IR, is very simply Q3 minus Q1. So in this case, it's going to be 24.5 minus 16.5, and that equals 8. All right. Let's try this one. We just had the class do this one on their own to see who can get it right. So we'll just work through this one together. The first thing we have to do, of course, is to order the numbers, put them in lowest to highest order. So we'll start with 8. I notice we have 10. We have 11. Looks like we've got 3 13s. We've got a couple of 14s. And I've got the number 30. Okay, let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're in good shape. Well, the range, we can go ahead and take care of that. The range is the highest number minus the lowest, and that's 22. For interquartile range, I need to find the quartiles, and that starts with Q2. All right, so with an odd number of data points, my median is shown. Okay, the number in the middle of this data set, we call Q2, is 13. And that divides my data up into 2 groups of 4. And so over here, the one that's in the middle would be 10.5. It's Q1. Over here, well, between 14 and 14, that is 14. It's Q3. And now just to find interquartile range, I just take Q3 and I subtract from it Q1. And I get my interquartile range, which is 3.5. Okay, so some of your homework problems look just like that. In fact, the first 3 problems, 1, 2, and 3, will be doing just this. All right. Then we get into another statistical measure that helps us determine, compare data in regards to its dispersion from the mean, and that's known as standard deviation. This is one of those measures that you see pretty commonly in statistics, either a statistics class or other courses that involve statistics. All right, well, I'm going to walk you through a process, and I want you to use this same method to eventually, we're just going to work our way to the right so that we can eventually get to this standard deviation formula. All right, so I've attempted here to reproduce lowercase sigma. And when you see lowercase sigma in statistics, that stands for standard deviation. And then under the radical, another Greek letter, Greek symbol, and this is uppercase sigma. And in math classes, when you see this uppercase sigma, it looks kind of like an E shape. That always means summation or summing, add up a list of numbers. Okay, so once we finish working our way through these columns, we'll be able to naturally flow right into this formula to find the standard deviation. All right, so first step, I just went ahead and listed vertically the numbers that were given, my data. Remember back in the previous section, 12.3, X bar, X with in this case, the blue bar above it, that stands for mean or average. So the first thing I've got to do is come up with the average of these numbers. So remember, that's adding them all up and divide by the number of numbers, and there's 8 numbers in this case. And you should get an average or a mean of 80. Now, 80 should really fill up this whole column, but I'm not expecting you to just write the number 80 8 times. I usually just write it once and then show that I'm just going to fill that whole column with the number 80. Okay, moving to the right, I have this column that describes my data, which is in the first column in red, minus the mean. So I'm just going to go through one at a time and do this subtraction. So 50 minus 80 is negative 30. 60 minus 80 is negative 20. 70 minus 80 is negative 10. 80 minus 80 is 0. 0 again. 90 minus 80 is 10. 100 minus 80, and then 110 minus 80. Okay, that takes care of that column. Okay, well, this column heading says, take that number that you just got from the previous column, take each of those numbers and square them. It's really all it means to do. So each one of these numbers, one at a time, we're going to square. Now remember, tried to point this out in class today, you should never have a negative number in this column, because negative numbers, when squared, always become positive. But a common mistake that I see, maybe it's just people not paying attention, is people putting something like this in their calculator, and if you enter into your calculator exactly like this, your calculator is going to say the result is negative 900. Because what you've told the calculator to do by order of operations is to square 30 and then change it or multiply by negative 1. Well, that's not what this means. We need to square the number negative 30. So if you need to, if you're not going to do this in your head, you need to make sure you put parentheses around negative numbers so that you don't just write down what you see on the calculator display. And I see that happen sometimes, and it throws off your answer. Okay, with that said, let's just continue on. Negative 20 squared is 400. Negative 10 squared is 100. Of course, these are both 0. 100 squared, or 10 squared is 100. 20 squared is 400. 30 squared is 900. Okay, now looking at my formula, looking at the numerator, if I were reading this in words, it says, remember, this means the sum of, or sum, the column that has this heading. So this is the only column that I need to really find a sum of, the summation of this column. Okay, so we can probably do that, or you can use your calculator. 13, 14, 1500, 1900, 2800. All right, so we're almost ready to calculate the standard deviation. And again, that's just the symbol for standard deviation, lowercase symbol. And we'll find it by doing the square root of this fraction. Remember, this is the sum that we just came up with for that column. So my numerator underneath the radical will be 2800. And n stands for the number of terms in my data set, and there are 8 numbers. And so make sure you do the square root of this entire fraction. All right, and I'm going to go ahead and do that to make sure I remember what the answer is. So it's the square root of 2800 divided by 8. And round it to the nearest tenth, which is what you can do in your homework. You can round these to the nearest tenth. You should get 18.7. And I was just alerting the class today about another common mistake people make in using standard deviation formula, and it's right here. I see some people who will do the square root of the numerator and then divide 8 into that result, and you need to be careful about that. It's the square root of the whole fraction. Okay? All right, let's see if we can work through one more of these. So think about if all you're doing is finding mean and standard deviation, you really don't have to order these numbers. You can just list them vertically, and maybe I'll get you to a certain point and you can take it from there. Okay, so here are my numbers in the data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. think I got them all. Okay, first thing I'm going to do is find the mean. And if you add all of these up and divide by 9, you should get 14. And I'm just going to show that I'm going to fill this entire column with 14. Okay, the next column is basically first column minus second column, all the way down. 13 minus 14, 10 minus 14, 11 minus 14, 8 minus 14, 14 minus 14, 13 minus 14, again, 14 minus 14, and 30 minus 14. Okay, next column is to take those previous numbers in the previous column, and square them. So -1 squared, -4 squared, this would be 9, 36, 0, 1, 1, 0, 256. And this is the column that we need to come up with the sum of. So let's just run through this real fast. Just take your calculator, come up with the sum, and we get 320. Okay, so your standard deviation formula looks like this. It's the sum, I'll write it out, and then we'll replace the sum of that column divided by the number of terms in your data set. So the sum of that column is 320, and I have 9 terms in my data. So I'm going to do this in my calculator and then round to the nearest tenth. And we end up with 5.9628, but when we round that to the nearest tenth, it bumps it up actually to the nearest whole number. So I'll show you what the calculator display shows. But rounding to the nearest tenth means we look at this number, which bumps this up to 0, which automatically bumps this up to the next one, or whole number. All right, so there's your answer. The mean was 14, standard deviation 6. Okay, my last topic is z-score. What do I mean by z-score? Well, I've given you a definition that you'll want to make sure you get in your notes in blue. Z-score tells us, again, it's all about how far away a particular number in our data is from the mean. And this time it's determining how far away it is in terms of standard deviations. That's really what z-score is all about. And there is a formula to determine z-score. Value is just a fancy way of saying one of the numbers in our data set. So it could be 13, it could be 14. Okay? Value, one of the numbers in our data, minus the mean, divided by standard deviation. It's how we calculate what is known as z-score. Okay? So on the next slide, this number line isn't required for your homework. I'm just providing it as another example to illustrate the z-score answer. Okay, so let's just use our formula to come up with the z-score. So just write out z-score equals the value, which in this case we're given is 76, minus the mean, and the mean is given as 85, divided by the standard deviation, which was 6. And if you just do this in your calculator, you get -9 divided by 6, and that's -1.5. Okay? Well, just to illustrate this number in a graphing sense, so I just thought I would provide this number line to just kind of give some context to this number. I hate to just throw a number out there without you getting a little bit of a feel for what this actually is talking about. So what I've done here is I've just drawn a number line, and since the mean is 85, I just put 85 right in the middle of this number line. And I'm told that the standard deviation is 6, so that's what I used as increments in going up. I just added 6 to each number, and going down I'm subtracting by 6. So each one of these numbers represents a standard deviation. Okay, each of these ranges is a standard deviation. So it's pretty simple really, but if we did plot the number 76 on this number line, then it would go right in here. It's right in the middle of 73 and 79. Okay, well here, remember, z-score is all about a number's position relative to the mean, but it's in terms of standard deviations. All right, so here I am at 85. If I'm going to the number 76, I'm going to travel 1 standard deviation, okay, because a standard deviation is 6. And then I'm going to go another half standard deviation. And I went to the left, or in other words, the number is below the mean. And so that's kind of a reason why the z-score is negative 1.5. It's negative because it's below the mean, and it's that number of standard deviations below the mean. 1 and then another half of a standard deviation. Okay, we'll try one more. If the mean is 85 and the standard deviation is 6, then what is the z-score for the number 100? So we do value minus mean divided by standard deviation. 100 minus 85 is 15 divided by 6. And when you do this in your calculator, you should get 2.5. So the number 100 in terms of standard deviations is 2.5 standard deviations above the mean. And that makes sense because 100 is larger than 85. All right, and so you'll be doing that, it looks like on numbers 10 through 14 near the end of the assignment. So that's pretty much it. Not a long assignment. The standard deviation problems will probably take you a little bit, but we'll see how you do on these tomorrow.